Hi, everyone. This is Jim Cahill with another Emerson Automation Experts podcast in our continuing Asia Pacific Sustainability and Decarbonization podcast series. Today, we're going to explore carbon capture technology with Emerson's Willie Tan and Amy Loi. We'll look at some technologies to optimize the carbon capture process. Welcome, Willie and Amy.
Hello, Jim. Willie here.
Hello, Jim.
Well, it's great to have you both with us. Willie, let's start with you. Can you share a little bit about your current role and some background on your experience with our listeners?
Yeah, sure, Jim. Hello, everyone. My name is Willie. I'm the hydrocarbon industry manager under Flow Controls. My industry and working experience background are specialized in oil and gas, LNG, refinery, and petrochemical. I have been with Emerson for 10 years and based in Singapore. I have been involving in technical and sales support as well as business development role in sustainability and renewable energy that covering hydrogen, renewable diesel, carbon capture, utilization, and storage or CCUS. It is my pleasure to join this podcast to share my experiences and my expertise in control valve segment in carbon capture technology. Thank you, Jim, for this invitation.
Well, glad that you're here with us. And with that background, I think our listeners are going to get a whole lot out of it. Amy, can you give us a little bit of your background? Tell us a little bit about yourself.
Sure, Jim. Thanks for having me today in this podcast session. My name is Amy Loi. I'm the Sales and Marketing Director for Analytical Products. I have been with Emerson for the past 20 years in various technical, sales, business development, as well as the marketing roles. With the recent focus in sustainability and decarbonization, I have been tasked to lead the brownfield sustainability, which covers the emission control, energy efficiency, and carbon capture for Asia Pacific, and participate in other sustainability and renewable energies segments such as hydrogen, biofuels, and batteries. Our primary focus within the brownfield sustainability is to create awareness of Emerson's solution and partner with our customers towards their decarbonization journey.
All right. Thank you, Amy. So let's dive a little bit into carbon capture, utilization, and storage, or CCUS. Since that's such a mouthful, we'll refer to carbon capture, utility, and storage as CCUS throughout the podcast. Willie, can you define and describe CCUS for us?
Thank you, Jim, to direct this question to me. Well, why the carbon capture is important? As all of us know, carbon emission is one of the main causes to the global warming, which must reduce the carbon emission to avoid the greenhouse effects from getting worse. So, how the carbon can be captured? There are many different technologies available in the market, such as using the solvent, adsorption, desorption, and membrane separation methods. What is next after the carbon was captured? The CO2 will be compressed and transported via pipelines, trucks, or ship to storage destination. The last step in CCUS is either injecting the CO2 into the ground for permanent storage or use it for other industrial purposes. Let me share two examples of carbon utilizations. First, the carbon dioxide can be used in oil and gas industry for enhanced oil recovery or EOR by injecting the CO2 into the oil and gas reservoirs. The second example is the chemical processing plants utilize the carbon dioxide as feedstock to produce chemical products such as urea, methanol, and carboxylic acid.
Well, that's interesting that it does have a number of industrial uses, and also there's places to store it in like depleted oil production platforms. So thank you for that nice description there, Willie. Amy, what's CCUS's role in net zero emission, and how does it help with carbon dioxide reduction on a large scale?
Actually, Jim, time is really running out for us if we want to achieve the zero emission target by 2050. And CCUS could be the most important game changer. Just now, Willie and you also have heard and mentioned about the different industries that emitted a lot of carbon and a CO2. So the carbon capture facility can be retrofitted into all this industry or companies that is emitting a lot of high intensity carbon, like coal-fired power plant, cement, iron and steel, and many other chemical sectors, which actually have a lot of industrial processes and high temperature heat requirement. So CCUS can contribute to about 16% of the CO2 reduction in the power generation sector. It can also be used to reduce 90% of the CO2 in fuel transformation sectors, such as refinery, petrochemical, and chemical processing plant. CCUS actually is one of the most mature and cost-effective alternative for driving net zero emission in industry facilities. I recall there is one time that I have read in the IEA Sustainability Development Scenario that 40 metric ton of CO2 was captured by CCUS in 2020. And it is predicted that up to 5.6 gigatons of CO2 will be captured in 2050. Based on this huge growth of carbon capture, we can foresee a lot of investment in the CCUS technology in the next 20 to 30 years. That's how we see the importance of CCUS in the carbon reduction globally.
Wow, that's pretty massive, from 40 megatons to 5.6 gigatons over that span of a couple decades. That's tremendous. So what's the current global status of CCUS, and how has it progressed so far?
Jim, thank you for another good question. Based on what I have seen in the global project funnels, there are many CCUS project activities which are ongoing in North America, Europe, as well as Asia Pacific regions. There are 135 CCUS projects worldwide, 27 of which are already in operation, 4 under project construction, and the rest are under development plans. Looking at each region, 40 projects happen in North America, followed by 35 projects in Europe, and also 5 new projects we have seen in Asia Pacific, which were announced recently. Indeed, you might be surprised with the number of CCUS projects and development plans across the regions. So you probably are interested to know what are the key factors that encourage the growth in the CCUS. Based on my observation, in the CCUS global status, I found 2 key drives for CCUS momentum. The first key drive is the country policy support and investment, such as incentive scheme for CCUS research, development, and project execution. With the government policy support and investment, it really helped us to boost up the CCUS technology and development. The second key drive is the carbon net zero commitments globally. I believe everyone has heard about the Paris Agreement. It was negotiated and signed by 194 states and the European Union. The objective of having this Paris Agreement is to strengthen the global response and support to keep the global warming to well below 2 degrees Celsius. Amy, can you share your professional perspective in CCUS global status, and what have you seen in the CCUS development?
Thanks, Willie. Yes, I do have something to share as well. We have observed a shift in the deployment strategies from large standalone CCUS facilities to the development of industrial hubs with shared CO2 transport and storage infrastructure. This approach can improve the economics of the CCUS by reducing the unit cost through economics of scale and reducing the commercial risk and financial cost by separating the capture, transport, and storage component of the CCUS value chain. But developing of CCUS hubs with shared infrastructure can also make it very visible to capture the CO2 at the smaller industrial facilities, for which dedicated CO2 transport and storage infrastructure may be impractical and uneconomic. This can also allow the continued operation of the existing infrastructure and supply chain in the industrial region, while maintaining the employment and making it easier to attract new investment overseas as well as domestic. And this includes the energy-intensive industries or low-carbon hydrogen production, while trying to meet the emission reduction targets that each of the companies as well as the country is targeting.
Well, that hub approach does sound like a good path to more efficient CCUS operations. Amy, what will the growth of CCUS do to create additional economic impacts?
Jim, CCUS is really indeed will create a lot of additional positive economic impacts. CCUS help cost effectively convert the high emission intensity industries to near zero emission industries as one climate mitigating technology. As more companies and countries invested in more CCUS projects, it will create a lot of branches of job opportunities across many sectors or disciplines, such as engineering, design, construction, commissioning, as well as processes. When all these plants are up and running, we will need more technicians and engineers in the maintenance and operation of these CCUS facilities. The CCUS brings encouraging and impactful growth to global economics.
Well, it's good to hear about that there's growth opportunities in there for the businesses undertaking that. Willie, can you share which countries in the Asia Pacific region are actively involved in CCUS development and some of their project execution plans?
Jim, it is an absolutely great to hear about the optimistic economic growth that driven by CCUS project, as what was shared by Amy earlier. So, in my observation, there are couples of good examples in CCUS development plans in Asia Pacific. We are seeing 5 new CCUS projects that happen in China, Australia, Malaysia, and Indonesia. In China, they had announced their support in CCUS by launching the emission trading scheme, which covering more than 2,000 power plants. In Australia, the CCUS was added into their emission reduction fund with 300 million for CCUS project. And also we are exciting to see Southeast Asia countries, they are investing in CCUS project such as at Sarawak in East Malaysia, and also the CCUS hub that happened in South Sumatra in Indonesia.
Okay, that's excellent. All these different projects going on. So let's get a little bit more specific to what we can help with. Amy, what role can Emerson play in CCUS technology?
Well, Emerson, as one of the largest companies in automation solution, plays a key role in solution provider and close partnership with global process licenses as well as EPC, who are specialized in CCUS technology. We have decades of experience in engineering, operating, and optimizing industrial facilities, which provide us with the foundation for expertise in CCUS. Our automation technology has the flexibility to quickly and efficiently adapt as carbon capture technology evolves, ensuring our expert can help our customers navigate regulatory uncertainty as they plan and execute CCUS projects. Our expert also understands the unique challenges posed by the CO2 transportation and storage, bringing the integrated geoscience and engineering capability needed to successfully plan and execute carbon storage projects widely. In order for us to ensure that the carbon is permanently sealed away, it's critical to achieve the operational and environmental goals of a CCUS project. Emerson leveraged its highly advanced technologies in well integrity management, effectively closure technology, and ongoing monitoring services to help our customers achieve this objective. We also have the gas compression technology and advancement compression and pumping solution address the most demanding industrial decarbonization projects. Our vast experience and expertise with the LNG operations can be applied to the CO2 liquefaction due to the similarity in the nature of LNG and CO2. And the list goes on. These are just some of the examples which specifically address some of the key pains which we are helping our customers solve in CCUS projects, or I would say design to prevent or minimize future issues that these CCUS plants will face.
Well, you made a good point there. All the experience that we've had working on the liquefied natural gas and some of the similarities with it, transporting it and liquefying carbon dioxide. So a lot of those technologies can cross over into it. So great point there. Willie, can you share some specific Emerson products which support CCUS?
Yeah, sure, absolutely. Based on my expertise in control valve and experiences in CCUS, there are many control valve applications that are happening at the carbon capture, pipelines, storage, and a different industry applications where the carbon dioxide is utilized. At the carbon capture section, Emerson offers feature control valve for fuel gas flow control at combustion furnace, as well as the cryogenic valve application at the cold fractionators. At the CO2 purification unit, Emerson offers dim amine and rich amine level and flow control valves, which are located at the amine absorber and regenerator unit. Besides, Emerson has proven reliable control valve with extended life cycle for high cycling applications such as at the PSA or pressure swing adsorption, which is commonly used to separate the CO2 from other gases. At the CO2 transfer application, Emerson offers compressor and discharge feature control valve, which is a critical and important valve to protect the compressor from during the surge event. At the CO2 utilization segment, we have a huge install base in oil and gas and chemical industries.
Jim, I'd like to add on to the examples that Willie has shared. May I?
You bet. Go for it.
In the transportation and injection into the well part of the CCUS value chain, a few customers have approached us to recommend the most reliable mass flow measurement at the supercritical condition of the CO2. Our recommendation is to use the Coriolis technology for this particular application. At the point of injection of CO2 into the reservoir, the pressure of the CO2 is typically very high, causing the density and the behavior of the CO2 has changed. The volumetric flow measurement will be difficult due to the changes of the CO2 phase and density. So, the direct mass measurement is the best option at this critical measuring point. Another application is on the corrosion and erosion monitoring to ensure pipeline and process integrity. Any presence of moisture in the CO2 will cause the formation of carbonic acid and may attack the pipeline or process unit. Online monitoring of pipeline and process unit corrosion is important to avoid leakages and spillage. Depending on the location of the installation, the corrosion monitoring solution can be wireless, which means wirelessly transmitting the data to the control system for the monitoring purpose instead instead of laying long length of cable or manually getting the operators to go to site to measure the thickness of the pipes to ensure there is no corrosion happening in the pipeline. The last application that I wanted to share today is on the concentration or the composition measurement of the CO2 purity and impurities at the carbon capture units or process and further down the value chain. The purity or the impurity analyzers will provide near-live data to the operators. This means visibility into the process. Operators will be able to take quick action if the impurity levels exceed the set point. And every process is different depending on the carbon source, whether it comes from natural gas, post-combustion process, or direct air capture. The species of the impurities measured can be very different.
Wow, you've given a real broad overview between the control valves for some of those really difficult applications like on centrifugal and axial compressors where surge is critical to be able to prevent that, to mass flow measurement instead of volumetric flow that we can have with micromotion Coriolis technology, corrosion and erosion monitoring, making sure that the pipes and vessels are sound, and then the analytical equipment measuring the purities and impurities. And I know that's not a complete list, but that's really a lot that can help across the whole carbon capture, utilization, and storage chain that's going on there. So can you tell our listeners about a few examples demonstrating our partnership with customers in their CCUS projects?
Sure, Jim. Let me give you two references where Emerson feature control valve was supplied for CCUS project. So the first example is a CCUS project that happened in Australia. Emerson has supplied high pressure rating control valve for an oil and gas customer to capture the CO2 from offshore gas field and store the CO2 into the ground. And the second example is Emerson feature control valve are used at the direct air capture, or we call it DAC. The DAC was designed by a Canadian company. Their DAC is capable in removing 1 million tons of CO2 from the atmosphere annually. The current project was a pilot plant. For the full-scale plant, its capacity can be 10 times or larger.
There are a couple of projects that we partner with our customers, which I want to share as well, Jim. We have a fertilizer manufacturer in India who has been buying its CO2 from a gas supplier. Due to the supplier's unreliable supply of the CO2, the owner has decided to generate their own CO2 by installing a post-combustion carbon capture unit. We have supplied the CO2 purity analyzer, flow meter, and valve to these customers for their carbon capture plant. This project actually started up in 2016 and was fully operational in 2017. It was a relatively short design and execution timeframe project. Our customers' experience is so good that we have repeated orders from this customer. And in another partnership with an oil and gas customers in Australia, this customer has chosen Emerson as a supplier for their CO2 custody transfer skids. The skids consist of Coriolis flow meters for CO2 measurement at high pressure and supercritical phase, CO2 purity measurement, and impurity measurements analyzer as well.
Well, that's a pretty wide range of the portfolio we have, from final control and measurement and analyzers and the things that we have. So it's great to see, especially going back to like 2016 on some of this. So a lot of field experience there. So Willie, I guess, can we offer live or remote demonstrations to listeners that may have heard this podcast in their facilities who are interested in reviewing, the breadth of products we have and their capabilities?
Hi, Jim. I would say it is our pleasure to invite all the customers to Emerson Asia Pacific headquarters in Singapore. First, we have a compressor and discharge valve demonstration unit at Singapore office. The compressor and discharge valve is connected to a compressor controller. We can simulate the compressor and discharge event and demonstrate how best is feature control valve perform when the such event happen. And the second one, we have an additive manufacturing center, which is the 3D printing technology. The additive manufacturing is an advanced technology to overcome the limits of standard manufacturing processes. Emerson is now using this 3D printing technology to produce high-tier material as well as the special valve designs and solutions for our valuable customers. I would like to welcome all listeners to this podcast to our facility in Singapore. Please feel free to engage us if you are interested to know more about feature and discharge valve and our additive manufacturing technology.
Yeah, that 3D or additive manufacturing process is amazing because you can do things you simply can't do through traditional methods. I've seen it on different ways to quiet the flow through a valve and some of the things that they can create. So yes, it's definitely worth someone's time to connect with Emerson and get a tour and visit the headquarters there in Singapore. Well, I want to thank you both for sharing everything happening in CCUS in the Asia Pacific region. Let's close out this podcast by telling our listeners where they can go to learn more about Emerson solutions in CCUS.
Our listeners can visit our Emerson Sustainability website to learn more about our strategies, technologies, and solutions. You may also contact our nearest Emerson office and speak to our Emerson Sustainability and Decarbonization representative. In addition, we have lined up a series of webinars with different topics related to sustainability and decarbonization. For those who are interested, you may sign up to learn more details.
That's great. Thanks, Amy. And I want to thank you both, Amy and Willie, for joining me today in this podcast.
Right. Thanks for having us here today, Jim.
Thank you, everyone. Have a good day.
All right. And we will have some more in our continuing series in the Asia Pacific Sustainability and Decarbonization podcast. And make sure to visit the page where you can learn more about it on emerson.com. And for those in the region, make sure to visit our page of where our experts are in your country. For now, bye everyone.